USACO 2015, January, bronze 4 meeting times. Bessie and her sister Elsie wants to travel from the barn to their favorite field, such that they leave at exactly same time from the barn and also arrive at exactly same times for their favorite field. The farm is a collection of n fields. N is smaller equal to 1, bigger equal to 1, and the small equal to 16, are numbered 1 to n, where field 1 contains the barn and field n is the favorite field. That means the final field is favorite field. The farm is built on the side of the hill, with field X being higher in elevation than field Y, if field Y is the bigger than field X. On a sort of M path connect a pair of fields. However, since each path is rather steep, it can only be followed in a downhill direction. For example, a path connecting field 5 with field 8 could be followed in the 5 to 8. In this case, 5 is the smaller than 8, right? So in this case, X is the higher. So we can downhill. Does this make sense? Direction, but not the other way. Since this would be uphill, each pair of fields is connected by at most one path. So M is smaller, equal than M multiply n minus 1 divided 2. I think this equation is not important for this question. It might take Bessie and Elsie different amount of time to follow a path. For example, Bessie might take 10 units of time and Elsie is 20. Moreover, Bessie and Elsie only consume time when traveling on paths between fields. Since they are in a hurry, they always travel through the field in essentially zero time, never waiting around anywhere. Please help determine the shortest amount of time Bessie and Elsie must take in order to reach their favorite field at exactly the same amount. Okay, let's create input. This is input, right? This is same as this one, right? Okay, cool. And then output is it. So in this case, this first input line contain n and m. So this is n and this is m. M means the number of paths. Paths is now there are 3 paths. First is field 1. This is a barn to field 3. Bessie take 1 second, but Elsie take 2 seconds, right? And then barn to field 2. Elsie take 1 second. Bessie take 2 seconds. From field 2 and field 3, Bessie take 1 and Elsie take 2. Does this make sense? Okay, first we're gonna make a function to import bearing that in file. So we're gonna use import system and system standard input. We're gonna open a file and that is meeting dot in, and we are gonna use read mode, and then system standard out for to upload website. Open and meetings dot out, and this is white mode, and then temporarily I'm gonna disable to print out to console, and then we're gonna input first line 33. Actually we need only first one. M is no need, because later we're gonna get pass, and then we easy to get the length of pass easily. So n is, we're gonna convert it to integer, and then we're gonna import and split, and we're gonna use only first one. And then we are gonna make a pass array to put the pass data. And then we're gonna read a line one by one from system standard in, and then first the pass is append. It must be integer. To do that, we're gonna convert it with map, and we're gonna line and split. And then print. We're gonna make a new function. Name is meetings, and we are gonna to put m and pass as argument. Then now it's time to make meetings and m and pass. Okay, let's check the argument. Oops. 3. Why this is bad? We did convert it to list. So this is example. One input is, and it's this one, and second pass is this. And then output must be 2. Is this one. Okay, let's analyze the data. Why output is 2? In this case, pass is this is first pass is 1, 2, 3. In this case, best is it take 1 second, and the LC 2 seconds, right? And then 1 and 2, also 1 second, 2 seconds, and 1 and 2 and 3. It takes 1 second and 2 seconds, right? So, if the LC used this pass, it takes 2 seconds, right? So this is, LC is the slow, and best is fast, double speed, right? So how we able to do? Best way is BC going to 1 and 3, and it take 2, and then LC going to 1 and 2. It take 1 second, right? Plus after 2, from 2 to 3, it will take 1 second. So in case of BC 1 and 2, it take 1 second, and then 2 and 3, it also take 1 second, and then total it take 2 seconds. So if BC use this pass, they gonna meet same time, the 2. So we're gonna use this one. How are we able to do that? To do that, we need to traverse all of paths of field. To do that, we're gonna use DFS, and we're gonna make BC position, and this one must be, it start 1, right? So first is 0, 1, 2, 3. This is 0 index, 1, 2, 3. And then we're gonna use only this one. And we need to make, this one is, if n is 3, we're gonna make 4. Then this is 0, we don't need to 0 index. Only use 1, 2, 3. This is more easy to read. Even we waste a little bit data, but that is not a big deal. So, and then after that, we're gonna make, let me delete this one. We're gonna read it. So from 1 to 3. 1 to 3 means, this is 1 here, and 3 is this, right? So 1 to 3, Bessie take, before that we need to make one more. LC. Bessie take 1, 3. 1, 3, take 1. And then LC take 2. 2 seconds, right? And then 1 and 2. 1 and 2 means 1, 2. This one, Bessie take 1 and LC take 2. Finally, 2 to 3. That is, this is 2 and 3. In this case, Bessie also take 1 second. LC take 2 seconds, right? After to do that, we gonna use this grid, because this one is easy to find from and to, and then we also easy to find the time. And then we're gonna, if the 0 means there are no paths, so it take 0 second, right? And then also we also use Bessie time. It will consist of Boolean, and then the size must be maximum time is 1000 seconds, and then field maximum field is 16. So total time is less than 16 multiply 1000, right? So 16,000. So it must be 60,000. So let's say first, and then also make LC2. This is same. So when they Bessie and LC arrive at the N is this part, right? This is N. This is favorite field, and then maybe it if we use Bessie LC 1 to 3, this one it take 2 times, so this one must, this is 0 second, 1 second, 2 second. Bessie will start here because they use 1 and 3 directly, right? And then LC also able to use this one, 1, 1, right? Also this one too, because Bessie is 2, 2, because Bessie take 1 second from 1 to 3, and then 3 is the favorite field, M, right? So maybe data must be like this. And then next, what we need to do is check the 1 by 1. Okay, so 1 second, Bessie is able to arrive the 1 second, but LC is not. So checking, how about LC take 2 seconds? Yes. How about Bessie? But if we use different paths, and then Bessie also arrived 2 seconds. So we're gonna return 2. Does this make sense? Cool. So what is time complexity? Time complexity is the node of position. So it take big O m square, because this is n plus 1, also n, and then this one is n plus 1. How about space? Space also you take n square. Does this make sense? Cool. So first we're gonna make max time is 16 multiply 1000, and then make DFS, and then we need position, and then timetable, and then from and current time. And okay, let's make Bessie position. Bessie position. Zero, 55, n plus 1. The reason is you're gonna use 1. So this one is we do not use it. So to make the 4, n is 3, so we need the plus 1. and then for in range n plus 1. How about LC? String LC time must be first multiply max time. LC time is first and max time. And then output must be float NF because we need to find a small number. So we're gonna put a position from the past. So for first is from, and second is to, and next is basic speed. This one is from to basic speed, LC speed, right? So basic speed and then LC speed from pass. So basic position from is from to it take basic speed. Actually that is not speed, this is time. Take time. What is good for that? LC time, LC time. Speed 2 is the faster than 1, right? But time is different. We take basic take time and then LC time, LC position from 2. This is LC position. Oh no, time. To the time. And then we're gonna do DFS, basic position, and basic time, and it start from 1, and then current time is start time is 0, right? And LC also same. LC, and then let's make. DFS recursion has 2 parts. First is base case, and then second is recursion relationship. So in this case, base case is from n time. This is the if from is n means this is favorite time, right? It arrived n. We're gonna put time, current time is true, update true. That is, we can record arrive time. Then return, and recursion relationship is we need to traverse all of possibility for next. So for 2, this is from, so we're gonna make to next position must be range from plus 1 and n plus 1 because it until n, so we need to plus 1. So if position, next position from n to has time, that means that it has passed. That is the same meaning, right? In this case, we do DFS. We're gonna get position and same time, and from is changed to 2, and then we update current time, update position from and to. The reason is it going to the 2, it take this time. So this one I gonna update this one. Does this make sense? Cool. And after that, now we updated the table, this timetable, and then finally we're gonna check which time has true value between BASI and LC, BASI and LC time. So to do that, for I in range max time, if basic time is true and LC time also true, this time we need to return I. Otherwise, return. That means we did not find anything. Time sheet time true. Item assignment. AC time, AC time. AC time first item max. AC time AC max. Interesting. C time. C time is current time. Current time 0. We're gonna edit. Tray 1 to 4. Pass. C time. Is there any time? No. Time is this one. This is time. DFS. This is time also. First. Next time. Basic time. This is the same. Okay, so what is good? Let's see. Okay, just SC and LC because the name is duplicated. 2. Okay. Let's read website. Thank you.